Today, our founders will reveal the innovations that we've been working on, share our vision and offerings for the storage industry, and offer insights for successful storage strategy at the enterprise level. We will conclude with a fireside chat with one of our esteemed customers from 3VG. My name is Beata Stone, and I'm on the business development team here at Quobyte. I've been with the company for over 4 years since the time we started our operations in the US. I'd like to begin by introducing our speakers. First is Bjorn Kolbeck. He is the CEO and founder at Quobyte. Before Quobyte, Bjorn spent time at Google working as a tech lead for the Hotel Finder project. He was the lead developer for the open source file system ExtremeFS. Bjorn's PhD thesis dealt with fault-tolerant replication. And Felix Hupfeld. He is the CTO and co-founder at Quobyte. Felix manages Quobyte's technology and pushes development forward. Before Quobyte, he worked as a tech lead and capacity planner, Google's infrastructure team. He was the architect and project manager for ExtremeFS. Felix's PhD was on distributed storage. So without further ado, I will pass it over to Bjorn.
Thank you, Beata. And we're excited to have you here. As Beata said, we have 2 announcements today, but before I go into that, I would like to give those of you who don't know us yet a quick overview of what Quobyte is and what we stand for. Quobyte itself is a pure software storage-based storage system that we built around a parallel distributed POSIX file system. In the end, Quobyte looks like any other parallel file system like NFS share, or can also replace your local storage. As you could guess from our background, both Felix and I have experience in hyperscale computing. So both of us worked at Google, and we saw how a company of that size runs the infrastructure, and how this kind of efficiency and skill that Google has can also apply to the enterprise, and how everyone can benefit from that. And before our time at Google, we both worked at a high-performance computing center in Berlin, Germany, where we also did our PhDs, and we learned how scale-out computing, high-performance computing worked. And this kind of scale-out is what enterprises need today for applications like machine learning, data analytics, but also for the not-so-obvious applications like media entertainment, transcoding, 3D rendering. All of those are high-performance computing workloads, although most users don't know about that. So Quobyte brings those 2 worlds together to make sure that you have a storage system that can easily scale. And we have a different way of doing storage. Traditionally, storage is still appliance-based, but our core idea is that there's no reason for appliances. Back in the past, computers were mainframes, and someone famously said that there's only room for a handful of mainframes worldwide. No one needs more computers. And today we all have one computer in our pocket with a phone. So there's no reason why storage is still an appliance. That's old technology. We believe that storage should be pure software, something that you can download and run on any server, just like you do with databases. That's why Quobyte is built around this idea of deploy anywhere. You can download our software and run it on almost any x86 server, on the public clouds, or also in containers. It's just another application. If you know Linux, you'll know how to run Quobyte. Then Quobyte brings you unlimited performance. That sounds like a bold statement, but it is basically the scale-out approach that Google and also high-performance computing use. The idea is that you have an architecture that doesn't have bottlenecks and allows you to double your hardware to get twice the performance. So you start with 4 servers, you get a performance X, and when you go to 8 servers, you get the performance of 2X. It's as simple as that, and that works to hundreds of servers. So you can start small and then grow the installation as you like. And the last part of our vision is unconditional simplicity. We want to make sure that storage is something everyone can use. As I said, a Linux admin should be able to install and run a storage system. You shouldn't need a PhD in storage appliances to run that part of the infrastructure. It should be just another application. And part of the announcement today is that we will offer a free edition because we believe when storage is software, as we do, everyone should have the ability to just download and use it. So that's the first part of our webinar today, to tell you more about the free edition, what to expect, how you can install it, and give you a quick demo of how to use it, how to install it. Then the second part will be our new 3.0 release with new features focused around security. And then the third part is a fireside chat with Joe Chapman from 3V Geomatics. So the Quobyte free edition is available today from our website, and we'll show you how you can get that. It includes up to 150 terabytes of hard drive and 30 terabytes of SSD storage. For everyone who knows storage, this is raw. The usable capacity depends. So this is the actual space that you can use on the disks. And if you use the Quobyte free edition on the clouds, for example, through Google Cloud Marketplace or Oracle Cloud, you get 10 terabytes included. You have the full file system functionality plus S3 in the same namespace, meaning you can access files from the Linux mount and download them as an object, or upload objects via S3 and then modify them as a file. So unlike many other products, we put that in the same namespace to make sure that you can facilitate data sharing. And that's included in the free edition as well, meaning you can use Quobyte as a file and an object store at the same time. And then a lot of our standard features are included. So just like our standard product, you have full fault tolerance, meaning you install Quobyte on 4 machines or 4 VMs, and it's immediately fully fault tolerant. You don't need anything extra. Your data is protected. You have automatic failover, and also the Quobyte client will automatically switch to other servers. So there's nothing else you need. After the install, you have a fully fault tolerant system. Then you get the analytics included. So you can see which applications are running in your cluster, what the individual clients are doing, great insight into what kind of workloads your users throw at the system. Then the full toolset is included, our web interface, which got a refresh with 3.0, the API, command line tool. So everything is there for you to get started quickly. And then I'm particularly excited that we also include the full Kubernetes support. So we have been very early on with including storage for Kubernetes. We had an in-tree driver and now switched to a CSI plugin. This works fully with our free edition. So you can use things like volume provisioning, which automatically creates volumes, but you can also use Quobyte itself in containers. We will publish our Helm chart probably this week that you can use to deploy a full Quobyte installation in containers. And I think that's particularly exciting because, as I said, storage should be just another application, and the container deployment is a testament to that. It's just another application on your Kubernetes cluster. And then in addition to Kubernetes, we also include the full set of native drivers that we have, for example, for Hadoop, TensorFlow, and also for MPIO. These are userland drivers that circumvent the kernel. So you get nice performance improvements, about a 30% latency reduction by avoiding the kernel. And that's all included in the free edition. And when we say free, we really mean that. It's also free for production use, meaning you can do whatever you like within the framework of what's legal. You can use the free edition on your own servers in the cloud, also for production workloads. We'll provide support via community forum. This is now available on our website. Our team will also monitor that and help, but we encourage our users to go ask questions, give us feedback on the product. And starting next week, we'll also offer weekly virtual office hours with our support and engineering team. That's also a great way to get to know our engineers if you're interested. We have a weekly rotation and we'll publish that on our website with the exact date. And if you want to try this, you also find this command here on our website. You basically run this bash script as an installer. You can also download it and look at the script if you don't feel comfortable running a bash script right there from the internet. Then in addition to the free version, we have a cluster edition for those that prefer enterprise support included. This cluster edition has the same capacity constraints as the free edition, comes with additional security features like support for X509 certificates, and starts at $8,999 a year for the subscription. So this will be available within the next couple of days from our website. And then if you think about the use cases for Quobyte in general, but also for the free edition, we have a focus on scale-out applications. So you can use the free edition to power machine learning workloads. As I mentioned, the TensorFlow plugin is included. You can run Hadoop, Spark, or general analytics workloads with the HDFS plugin, but also with our native file system driver. And in general, any scientific computing application. Then Kubernetes clusters, Quobyte is built in a way that we can run random IO workloads next to throughput workloads on the same storage system. So it's really great for Kubernetes clusters where you don't know exactly what kind of applications your users will run. So you can run the NoSQL database on Quobyte, you can run typical dev test workloads, continuous build, Git checkout and compile workloads, but at the same time also have throughput workloads like analytics on the same cluster, all running on Quobyte. And then you can use our hard drive and flash combination, for example, to provide high IOPS to your databases and cost-effective throughput storage on hard drives for analytics. Then you can use Quobyte for media and entertainment workloads. I mentioned these earlier. Editing, but in particular virtual effects and 3D rendering, which require much more scale out because of the compute intensity of the workloads, or transcoding. And in the end, anything that you have on a file system today or an NFS, and we'll talk about NFS a bit later with Joe. So if you have an NFS server somewhere and you need more capacity and more performance, you should definitely look at the Quobyte free edition to replace that. So we have pre-recorded a quick demo here to show you what you can expect. So we have a cluster with 5 machines here. It's actually running on packet.net. We run this command from the website. You can see it downloads it and then starts the interactive installer. First step is to change the username. So here we'll use root with the default SSH key. Then we provide the list of servers from a file. You can also copy and paste individual IP addresses, but a file is definitely more comfortable or convenient. Here you specify the clients and then we kick off the install. The installer logs into those machines via SSH. So you should be able to do that, for example, with an SSH key and then run sudo there. It will detect the operating system and do the proper install and also install dependencies like, for example, Crony for time synchronization. Then starts the services, the Quobyte services on the machine. Takes a moment because it goes to all the servers. If you have a larger install or more clients, you can also use our Ansible scripts that we published on our GitHub account to automate that. So this takes a minute or two until the installation is done on all the machines. So once the installation is complete, the installer gives you instructions how to add additional nodes later on and also client machines. And it will give you the address of the web interface where you can log in and you're greeted by the install wizard, the setup wizard, to walk you through the basic steps to get the installation up and running. License agreement, yes, fortunately that's necessary. Then you set up a admin account. So here we use admin Quobyte for simplicity. You can also specify an email address for notifications. License key, you can skip that and then you get the free edition for several days. You can just look at the system and if you like it, you can sign up for a Quobyte account and then get the permanent license key later on. So you can use the free edition forever. Once that's done, we're greeted by the dashboard. And you can see here that 8 devices need manual intervention. These are unformatted drives in new servers. And we tell Quobyte to format them for data and metadata so we can actually create a file system. We'll kick off those tasks in the background and depending on how big the drives are, the formatting might take a few moments. half of the devices have been formatted. We're waiting for the second batch of devices to be formatted. And then once that's complete, you can see the devices here in the tab, grouped by server. So we have more of a structural view of the cluster. We have the 4 machines here. Each has registry data and metadata. Then we have one client that we installed. It's here in /Quobyte. And we can log into the client machine via SSH. You can see the Quobyte mount here. The weird name there is Quobyte's name service in the cloud that we run for you. So you don't have to set up DNS records, but you can always change back to your own DNS records. Then we create a volume here, demo volume. And as soon as that has been created and stored redundantly on 3 metadata devices, it's visible in the clients. The clients have an auto mounter. And it's empty. We can create a file. And that's basically it. So you can see within about 4 minutes, you get a fully fault-run file system installed and up and running and can throw any application at it. So that's all you need. In terms of the machines, we have recommendations on our website. If you go to quobyte.com, you can click on deploy anywhere, and we have recommendations in terms of hardware, but also which virtual machine which virtual machine types to use on the public clouds. But you can always use your own setup, as long as it is a decent server with an Intel or AMD EPYC 2 CPU and direct attached drives or hard drives or NVMe drives. You can use that to run a Quobyte demo or Quobyte free version. Then the second part is that we will release our 3.0 version today. This is available for the free edition. So the free edition is actually based on 3.0. And the infrastructure edition with the full feature set of our commercial edition is also available. You can switch between the two by getting a license key from us if you want to see the full functionality there. The most important features included in this release are 360 security. So that has been a big focus for us in this release. An improved policy engine, a new user interface. For those of you who have used Quobyte before, you will have noticed that the free edition, the demo, had a different user interface. With that comes what we call My Quobyte tab, the ability to self-service. That's also tied to access keys. We added an auto file layout to give you better ability to switch between replication and erasure coding, and I'll talk about that in a moment, and then the native drivers that I mentioned. So 360 security is basically centered around the ability to protect your data really end to end. So with the data encryption that happens on the Quobyte client, you have the guarantee that no unencrypted data leaves the client machine. So your data is protected in transit at rest, but you can also work in untrusted environments where you don't have to trust the network, the storage system, the servers, or the administrators, because you basically know that all the data is encrypted and decrypted only on the client side. Then in addition to that, we added TLS support to make sure that all communication between servers and servers, or clients and servers, is encrypted and also authenticated. This is available or configurable by network. So you can use plain text connections in your data center to make sure you have high performance, and then use TLS encryption between all servers across data centers, for example, for multi-cluster setups. The advantage here is that the communication and encryption, TLS encryption, happens on all machines. So you have a nice mesh of communication mesh, and you get the performance of the scale out from multiple servers, and you don't have a central VPN gateway, for example, as an expensive bottleneck. And for this 360 security, we also enhanced the X509 certificate support to make them easier to manage. And we introduced access keys that everyone knows from S3 to the file system level, meaning you can use the same credentials for the S3 access as you do on Quobyte for the file system access. Users can get those credentials from the interface and then log into a client machine, or put those credentials into their Kubernetes deployment description, and then it's passed on to Quobyte through the CSI plugin. And then you have secure access to a shared file system in a container context. So it's a very powerful way for admins to secure the system without having to do any of the work, because it's self-service for the users. They manage their access keys and then use them whenever necessary through the different interfaces. Then the policy engine is new in the sense that we have made it more general. So unlike before, where we just we controlled volume and file placement through those policies, you now can control really all aspects of Quobyte, including the file encoding, the placement, tiering, also tiering between clusters, quality of service, recoding of files, for example, from replication to erasure coding, cache settings, and also file expiration immutability. And with the policy engine, you now have a better way of expressing those policies across multiple tenants, for example. So you can apply certain policies for the entire system. So you could say the entire system is encrypted, the data, or I want that just for one tenant or certain volumes. Even when you use tools like placement, you can even go down to the user and file level, meaning that certain files from certain users are always placed on flash, no matter in which volume they are. So this is much more powerful. But powerful also means that, you know, complexity is introduced in the system. And that's why we made a lot of the policies automatic. So they automatically pick the right erasure coding schema based on the number of servers you have. And then particularly interesting is the file layout. So we automatically switch between erasure coding and replication inside a file. And I'll talk about that in a moment. Then a new web console that you saw has been improved, not just from a visual standpoint, but also from a usability standpoint. Based on the experience we collected in our previous release, we made sure that things are more unified, feel more common when you use them, and it's easier to find the different options in the web console. The policy engine also got a nice UI where you can define the policies and see how they are applied. For example, here you see at the bottom level the global policies that are that apply to the entire cluster. They're standard or defaults, and then you can define policies here. For example, on the volume level, all volumes that have a label encrypted are encrypted, or all MP4 files are erasure coded with 12+4. So you have a lot of flexibility, a nice graphical editor to help you understand what kind of policies you have, to which targets they apply, and what they do. And then the out-of-file layout is particularly exciting for admins that have a lot of different workloads on their cluster. So when you select this option for file placement and encoding, Quobyte will automatically take the first parts of a file, the first few megabytes, and use replication and store them on flash. And then as the file is appended to, we switch to erasure coding and put the rest of the file on hard drives. So the great thing here is that this happens on the fly. So as the file is created, we don't need any information about the size of the file or the type. But when you have applications like machine learning, where you have a mix of very small files that are for metadata and then larger files with the actual images or video sequences, Quobyte will automatically put the small metadata files on flash for best performance and use replication so you have the best space overhead. And then for the larger files, you automatically get the bulk of the data on hard drives with erasure coding, saving you a lot of capacity on your drives. And this means it works out of the box for most applications. If you have users that run throughput workloads, part of the data will be on flash, but the 95% of the data will most likely end up on hard drives. And then you can also use our recoding to later on move everything in the background, for example, onto hard drives. That's also why the free edition comes with a mix of flash and hard drive. So you can run really both workloads, and small file workloads and large file workloads, on the same cluster. Our next topic is the fireside chat. I think before we go into that, we can open up for questions. Beata?
Yes. Hang on one sec. Okay, good. I am on. Yes, the questions. Let me take a look. And thank you, Bjorn. It looks like we have some great questions in the chat window. We'll try to get to most of them with the time that we have. Let's see. Our first question is, I'm not really comfortable downloading and running a random shell script. Can I install this manually? Bjorn or Felix?
Felix, do you want to take that as our CTO?
Of course, yeah. So we're very much aware that just the standard method that you see nowadays on web pages with a wget and install is not everyone's thing. It's easy and convenient, but of course, being real infrastructure software, you can install it the normal way, I'd say. This is not hard, actually. In the end, what the install script is doing is just adding the package repository. Unfortunately, there are a couple of ways to do that differently for every distribution. And then install Quobyte packages, set up NTP, and that's mostly it, right? So it's not, there's not a lot of magic that's encapsulated in the script, but it's just that shrinking down the experience to a single line.
Very nice. Thank you, Felix. Let's see. Another question is, what do you mean by almost any x86 server? Storage is usually an appliance. How would that work? Bjorn or Felix?
Yeah, I can answer this one. So almost any means it has to be decent server. You know, we can only be as good as the hardware. So if you find the crappiest server that you have lying around, then you will get mixed results, to say it nicely. But if you have any decent server like Intel Xeon, what is it, V4, or scalable processors, or the AMD EPYC 2, the Rome-based architecture, with, I would say, 128 gigabytes of RAM or more, a decent network, so 10 gigabits should be the minimum these days, plus drives that are attached to the server, so either with a HBA or NVMe's attached to the processor. If you have these, you can run Quobyte on it. The reason that appliances exist is because storage has been very hardware focused and more, or not really around software. The software is just there, but really tied to the hardware. The Quobyte approach is to make sure that you don't have this, and this is why we can allow you to run on almost any server. And then we do the fault tolerance across machines, and we have a lot of mechanisms built in to protect you from the hardware, because we don't really trust it. That's one of our core principles. So we have, for example, end-to-end checksums to detect broken drives. We have seen that with broken flash drives, for example. They start corrupting your data quietly, but also to find issues anywhere in your networking stack. We have seen network drivers that caused issues after an update and corrupt the data. So we have put those extra protections into the software to make sure that you can run an arbitrary hardware that's potentially unreliable.
Excellent. Thank you. Let's see. You said full Kubernetes support. What does that mean? Do you support persistent volume claims? Bjorn or Felix?
I guess I can take that. Yeah, it's in the end the current way of doing Kubernetes, which means CSI plugin, and then supporting the standard ways of integrating with your Kubernetes workload, which is persistent volume claims, both dynamic and static. And we map that basically to Quobyte volumes, meaning that you can both access existing Quobyte volumes through Kubernetes. And the great thing, because Quobyte is a distributed file system, you have what they call many reader-writer kind of semantics. So you can access the same file data from many pods on many machines at the same time. So it's a very straightforward and a nice way to integrate it in a Kubernetes environment.
Excellent. Thank you, Felix. Okay, here's another question. When you use erasure encoding plus replication, you said you keep the first 2 MB, if I remember well, on the flash and the rest of HDD. Is it really the rest or the entire file on HDD, meaning the first 2 MB resides at 2 different places? Would either one of you like to take that question?
Yeah, I think I can take this one and the next ones.
Yeah.
So EC plus replication means that the first part is replicated and potentially on flash. And then the rest is erasure coded and, for example, on hard drives. Generally, we're very flexible there. So in the end, we can cut up individual files at various boundaries and do specific placement for each part and use different encodings. So there would also, while it's not implemented yet, could also do a progressive encoding that probably after the first gigabyte, you start with a wider striping pattern or a different erasure coding scheme. So the data is not duplicated, if that was part of the question. The first part is really just on the flash, and the rest is then just on hard drives. I'll just take also the next questions. I see them on my screen. Thank you, Bertrand. If we use this, do you use a specific database for metadata, NoSQL? Yes, we do. We have our own database system and have been basically working on that for quite a while. The reason is that our metadata and both our metadata and our registry are distributed services, which means they're highly available, fault-tolerant, and most importantly, also split brain safe, meaning that you can basically shut down a machine, pull network cables, and so on and so forth. They will always be available as long as two out of 3 replicas available. And this is nothing that's offered by any existing database management systems. And so we started very early on investing in our own database backend, which you can imagine as a probably NoSQL kind of thing. It's in the end a key value store with a lot of focus on replication and a lot of focus on optimizations for the specifics of file metadata. The next question is, erasure coding works at the file level. What is the chunk size? Yes, the erasure coding works at the file level, meaning that we basically do redundancy within the file, but across nodes, of course. The chunk size depends a bit on what you mean by chunk. I mean, we have a very small block size, which is basically unit of read, modify, write, which is 4K level. In the end, it depends on what you mean with chunk. Because of our, let's say, policies and placement engine and so on and so forth, working at file level also means that we can pick the encoding profile via policies. We can have files with A+2 encoding in the same file system as replicated files or 2+1 files. And you can have various filters matching whatever policy is invoked. Björn, did you have an idea about chunk size? Do you want to add something?
Yeah, I think, as you said, it depends on the actual settings, but the default, if I'm correct, is 2 megabytes per chunk, and then you have A+3 chunks that are distributed across the service. I think that's probably the closest answer. Yeah, and then it's the file is basically striped into rows of 8 plus 3 2 megabyte chunks, and then those are distributed to the server, and then the next row, it goes basically round robin. So the first chunk and then the 9th chunk will end up on the first server. I hope that answers the question.
Here, there's a chunk. Here, the refinement is chunk means here the quantity of data you distribute on each system. On each system. Yeah, so it can be a couple of gigabytes. That would be, if that's a chunk, so a large file is split into units, and for a specific disk, it would receive of a very large file up to a couple of gigabytes of an individual file. Then the next question is your erasure coding systematic or non-systematic? I'm not sure what that means.
I think I'm not an expert on erasure coding, but I think that means that we also have extra functionality to detect that which block has been corrupted. So in addition to the erasure coding, we still have our end-to-end checksums on a block level. So if we see that the checksums don't match, we know whether the parity or the data block has been corrupted, and then can do the correct repair. I hope that answers the question. So that makes the erasure coding more powerful than if you don't have the extra checksums, which would tell you which part is defective, and then your repair functionality is limited. I hope that's the answer you have been looking for.
All right, our next.
Oh. Yeah, there's clarification. Systematic means you keep original data and add parities. Non-systematic means everything is scrambled. So yeah, in this terminology, we have a systematic erasure coding. So keep original data and add parities. Of course, for storage, I guess you likely always want that, because in the end, for reads that don't see any part of the data missing, you don't have to do any computation. Yeah. Then the next question, is there a snapshot feature like ZFS or ButterFS in Quobyte 3.0 release? Yes, there is a snapshot feature with Quobyte 3.0. It is not like ZFS or ButterFS because there are totally different architectures and a different environment, right? They're both local file systems. We do have a snapshot feature that's basically a snapshot mechanism translated to a distributed file system. It gives you undelete and then also access to old version of your data.
And it comes with a metadata snapshot. So you have the directory tree at the point in time, and users can go into a .snapshot directory and also retrieve the files. So it's, you have full read access, and also the idea of self-service to, for example, get your files back that you deleted accidentally. Yeah, who would do that? Who would accidentally delete the files? Never happened to me.
All right, our next question is, will the policy manager allow us to store all new data as replicated on Flash for 24 hours, then migrate it to erasure coding automatically after that first 24 hours? Bjorn or Felix, would you like to take this question?
Yeah.
Yeah, that's exactly the recoding feature. So you can define policies when to start the recoding, and then the recoding could say, okay, anything that's a large file should be completely on hard drives and completely erasure coded. And you can also say, I want, as Felix mentioned, I want to use a wider schema like 12+3 to save even more space for those large files. So that's part of the recode functionality in 3.0.
Excellent, thank you. We have time for one more question. Let's see, in coding theory, a systematic code is any error correcting code in which the input data is...
We had them already.
Okay, never mind, I'm so sorry. Well,
yeah. I see two questions which I can quickly answer, so if we're running out of time.
Yes.
one is the software already to find at the HCL list like certified VMware or Veeam storage? The answer is no. We're not listed there yet and not certified. And then another one, when you expose S3, is it S3 on top of your fuse layer, meaning you can do NFS and S3 on the same content? Yeah, so this is one of the strengths of, let's say, our file system first architecture. In the end, at the core, we're a distributed file system with POSIX functionality, but also, for example, supporting NFS, Windows, and NFS v4 ACLs. And so S3 for us is not a layer, but it's merely a protocol gateway, right? S3 is like also NFS or SMB, just another, or like Fuse, just another way to access the one and only file data that's stored in the file system. You can have actually workflows like ingesting data over S3, over the internet with all the security features that the HTTP protocol provides you. Then doing computation on that via a userland library from a large compute cluster, and then probably access it from an old, let's say AIX machine via NFS. And it's always the same data. You're always bound to the same access rules and ACLs that have been set on the data.
Excellent. Thank you so much. And it looks like we are out of time for questions. Thank you, Bjorn and Felix. We will now be joined by our customer from 3V Geomatics, Joe Chapman. I'll let you carry on, Bjorn.
Yeah, so I'm very excited to have Joe here today. He's the IT manager at 3V Geomatics. They're a Vancouver-based company that does INSAR, and this is where I'm struggling. It's basically they analyze satellite radar imagery for displacement or identifying displacement of structures. But I'm so bad at this that I will hand over to Joe to actually explain what it is, what they do, and why it actually affects every one of us. And it's a pretty cool tool. So please, Joe, tell us more about that.
Hi, Bjorn. Thank you for having me. Yeah, so 3V Geomatics is an INSAR company, which is interferometric satellite aperture radar. So essentially we take SAR images from government space agencies who have these constellations of satellites that orbit the Earth. And we compare the phase of two images that have been taken at different timestamps. And measuring that phase will give us an amount of displacement that is seen on the ground. Basically, that's what's called an interferogram, where the I in INSAR comes from. We can, because these wavelengths of these satellite radar images are so small, we can actually detect millimetric changes in the ground. Now, why would we want to do that? A lot of applications for INSAR include open pit mining, hydroelectric dams, pipelines, tunneling projects. We help solve a lot of complex problems. A lot of it is about safety and minimizing environmental impacts, and also with asset management of our customers. One of the bonuses to INSAR over, say, ground monitoring is that it's totally remote. We don't have to visit the site, though we can to get a better feel for what the site looks like. But to do the actual processing, it's completely remote. We just take images from space and give you a report at the end of the day.
Yeah, that's pretty interesting. I mean, thank you for explaining that, because it's I struggle every time. Whenever someone asks me, what does 3V Geomatics do? I try to explain it, and my summary is basically they make sure that bad things don't happen. That's in the end what it does, with a lot of technology behind it. I mean, we were introduced 2 years ago, and back then you were just looking at scale out solutions. And the reason that I'm so excited to have you here is that Your journey is kind of the coming from a traditional background and then moving into scale-out systems. And I think that's part of what we want to talk about today, like how your journey went and what you learned along the way. So maybe you can explain a bit, like, what does the pipeline look like? What do you, so the data comes in, you mentioned the agencies, the space agencies, the data comes in. What do your data scientists or researchers do with the data? How do they process it, and what's so challenging about that?
Yeah, maybe I'll take you through a little bit of the history. So we want INSAR to contribute to all asset life and environmental protection. That's like our end goal. We want to INSAR the whole world eventually. What used to be a nice to have, because in the past it was slow to get images, it was computationally very challenging. Clients would have to wait 6 months to find out if something moves, weeks or months ago, which was not very useful. But now there's more satellites in space collecting these images, and their frequency of revisits of the sites is getting more and more frequent. So we can now get near real-time reports, making real-time operational decisions for our customers. So like the reports are delivered to engineers, safety officers, construction managers. They use our reports for information for operations and to plan their future developments. We also have a project up in the permafrost in northern Canadian Arctic to help plan for safe construction up. Many of our SAR constellations, as I mentioned briefly before, are owned by government space agencies. We buy these images from those space agencies. In the case of Sentinel-1 though, it's actually, it's lower resolution data, but it's freely available. It's completely open source, so you can download it from an S3 bucket. These raw images are usually tens of gigabytes per image. Now, how do 3VG data scientists manage that data? You can think of it like a data cube. So, you know, you've got your X and your Y axis, but then you can take, because we're looking at a time series, you can take your Z axis and call that the time series. So it's like this cube of a stack of images. Often we'll need to drill down through the stack over time, pixel by pixel. We have to do all kinds of filtering, you can imagine. We have to remove the ionosphere, atmosphere, we filter out noise to get these understandable results. So you can imagine it's a very complex process.
Hmm. And so just to understand that better, basically it's like those images down here where it says radar image 1 and then images 1, 2, 3. So you get those, they are very large. One of those images is gigabytes. And then you have them from different points of time, and then you do pre-processing on them to remove artifacts like the atmosphere. And then your data scientists, or the applications, try to figure out what happened, you know, how did that one pixel, so to speak, change over time? So they have to go through terabytes of data to analyze that and run the simulations on that. Is that correct?
Yeah, for the most part, you can imagine each of our applications in our processing chain will create more and more data, and the output of the first step is the input of the next step, and then the output of that one is the input of the next one. So you can imagine our data actually balloons very, very big. We create a lot of intermediate data before we get to the final product, and then we can clean up the intermediate data from that chain. So our data is constantly expanding and then shrinking, expanding and then shrinking. So it's very, very hard on a storage system.
And that's talking about a lot of data. That's a good topic here. So I remember when we spoke for the first time in early 2019, you had joined 6 months prior. It sounds like a very demanding workload on the compute. So maybe you can describe you joined an HPC shop, or it sounds like a high performance computing shop, but maybe you can describe what you found and when you started there and the challenges that you had.
Yeah, when I joined 3VG over 2 years ago, we didn't consider ourselves like HPC. We're an INSAR company, but the workloads that we require for our processing sort of demands an HPC environment. When I had joined 3VG, we had already scaled out our compute. We had many compute nodes, and our jobs were managed by a scheduler. We had just started dabbling into parallelizing a lot of our workloads using GPUs. But when, at the time, we were still using these monolithic ZFS or ZFS for our American friends, storage servers. They were, one of them was just under a petabyte. Another one was, I think, 0.8 petabytes, like JBODs and JBODs of disks connected to head nodes, right? And it wasn't scaling for us. You have a whole bunch of compute nodes all trying to go against a single storage node at the same time, and it just locked up all the time. It was that was the state of our processing when I joined. So I was actually hired specifically to figure that out. What can we do to improve our storage situation?
But you told me that you came from a traditional IT background, and you were basically thrown in at the deep end. Like, here, we have a scale-out problem. Figure out our storage. So how did you go about that, and what did you do?
Yeah, pretty much. Before I joined 3VG, I was actually a Windows sysadmin at a previous company, and I was kind of at a crossroads in my career, and I just wanted to try something new. So I started applying for Linux jobs, and 3VG picked me up, and yeah, just like what you said, they actually hired two of us. One of them had much more Linux experience than me, so he got the Linux job, but they had this storage issue, and they didn't have anyone who had the time to really look into it. So that was my first job at 3VG, was to figure out what can you do about our storage situation. And the way I kind of looked at it was, we've already scaled out our compute, we're scaled out our GPU, so why can't the storage, be distributed across multiple servers? It just sort of made sense in my mind.
Yeah. And then after you looked at, okay, the storage needs to scale out, how did you look at storage solutions? What did you consider? How did you do your research?
About 6 months just learning about distributed storage solutions, and I sort of categorize them into three categories. There's a whole bunch of open source solutions that are free. A lot of them are, like university PhD projects, much like your Extreme FS that you guys started many years ago. And then there's also proprietary software distributed storage solutions like Quobyte. And then I also looked at, the typical proprietary hardware software package like Panasys or Dell Isilon, those kinds of solutions. And I just kind of ranked them based on what they had to offer and based on our specific needs. And Quobyte ended up being my top pick for the proprietary software solutions, and the one that we ultimately went with.
I mean, yeah, of course, I would like to know why you selected Quobyte. I have my own reasons why I would always pick Quobyte, but what did convince you to use it? I mean, we had a call, we talked about your problem, and then I basically sent you the instructions to download it. So what was your experience, and what was the moment, or what was causing you to say, yeah, that's what I want?
Yeah, probably what first caught my eye was Quobyte's unified approach to storage. I wanted to get away from these siloed storage solutions. So like we had two really big ZFS storage systems for different things. And then we also had a couple of smaller like FreeNAS servers for other things, and managing all these random systems was just a pain in the butt. So Quobyte's approach to unifying that whole storage system into one, where you can access it from, you know, their native client, NFS, S3, whatever, was really attractive. And then, yeah, we had that call, and you gave me the demo, and I whipped up some virtual machines and installed it. And I had a Quobyte cluster running in just a couple of hours, which was also great. It made it really, really easy to just, you know, test things out and see what it looks like and how it would behave. Like, what happens when I put some files on the system and then I shut down one of the VMs? Like, can I still access the file? And it was just awesome. It was so easy to use. It convinced me very quickly that I was on the right path with Quobyte.
And then, I mean, that's great to hear, but I guess you also had the performance that also worked for you. I mean, you suddenly had a scale out system. So how was the experience there? Yeah,
so when we decided to go with Quobyte, and we got some actual hardware and we installed it on proper hardware, it was like night and day when we were running our processing against Quobyte versus our big old ZFS server. It just, for one, the lockups that we were seeing before, which I just briefly touched on before, I didn't quite explain, but we were constantly, almost every day, having to reschedule jobs that had locked up on IO, particularly on NFS. And those just went totally away with Quobyte. And then at the same time, we also saw, I think, close to 10 times the throughput on Quobyte than we did with our single NFS server, which was super encouraging. And then from there, we just added more servers. We started with 4, then we got 8. Now we've got 18, I think 18 servers now in just over a year of deploying Quobyte. So and it's just super easy to add more. You just buy this hardware, install it, and put it in the cluster. It's awesome.
Yeah, it sounds like, you know, that switching to scale out storage helped you on the performance side and probably users. But it also sounds like it made your life easier as an admin. I mean, the NFS lockups, and anyone who knows me knows that I will not miss an opportunity to complain about NFS. I hate it with a passion, but it sounds like it made your life easier. So now you have more servers, but you spend less time on storage.
Yeah, exactly. Like even if hard drive fails or something, it's not that big of a deal because Quobyte just, you know, takes care of it. It pulls all the files that it knows were on that hard drive and replicates them elsewhere, and then it tells you, hey, you have a failing hard drive over here, and then you can just go and remove it when it's convenient. You don't have to, you know, shut down a whole server just to fix one piece of hardware, which is awesome. And even if you do, the system doesn't notice. Well, at least your end users, they don't know that you've shut down a server or two because they still have access to all their files, which makes things so much easier. So no more, you know, office-wide shutdowns because we have to, you know, or something on a storage server.
Sounds like the users are also happy with their results.
Yeah, absolutely. Operators don't have to, you know, poke IT to restart their job. Our R&D guys are super happy because they can just hammer it with whatever experimental program they're working on. And yeah, us sysadmins are much happier because we're not troubleshooting random hardware issues anywhere near as often as we were before. And we're also not so, you know, scared of losing hardware. It was touch and go with when you have like just one main production giant ZFS server. Like if anything goes wrong on that server, even if you have backups, the recovery time from that, just because it's so much data, is you know, you lose money just from, you know, being down for a day. So not having to worry about that has really enabled us to do all kinds of other things.
Yeah, I guess it's like when the users are happy, the admins are happy because Otherwise, they're like, why is my storage not working? Why is my job crashing? So I guess that it means
Absolutely.
happy admins.
For sure. Definitely.
Yeah, thanks for sharing this with us, because I think, it's a nice way of illustrating how this move from monolithic storage to really scale out software based works, and what the effects are when you are in the field. Maybe before we close this webinar, more on a personal question, how did this trend or this journey from traditional IT to scale out work for you? I mean, we met at Supercomputing last year, and I remember you were pretty excited about being immersed in that community. But it also sounds like, overwhelming. You were thrown in at the deep end and had to learn about all the scale-out technology. So maybe you can share with us how that experience was for you and what you learned about that.
Yeah, it's been a crazy couple of years at 3VG, because before working in like a small Windows shop, 1 terabyte to me was like a ton of data. And then I came to 3VG and we have like 16 terabyte hard drives. And then you go to a place like Supercompute and you learn about these supercomputers that are working with like hundreds of petabytes of data, which is just insane to me. So it's just it's a totally different world than like traditional IT infrastructure or regular sysadmin, but it's super exciting, and I'm really glad that I moved my career into this space, because it's just there's a lot of cutting edge stuff going on in HPC, and it's super exciting to be a part of it.
Yeah, and I'm glad you made the move, because it has been a fun experience working with you on this, and I would really like to thank you for sharing this with us and with the people here on the webinar. And
My pleasure.
Those of you that would like to have a similar experience, 3V Geomatics is always looking for great people to help them with their infrastructure. So if you think that's an interesting problem and you also like to learn about scale out on the job, then definitely look at 3V Geomatics. Also a great opportunity to use Quobyte in production.
Absolutely.
Yeah, I think that's all from our side. I can only recommend go to a website, get the free edition, use it for yourself, see whether you like it, give us feedback, discuss in our forum, and then follow us on LinkedIn and Twitter. We'll have more webinars coming in the next couple of weeks around different topics like security and containers. And don't forget to join our weekly office hours with our engineers and support team if you want to see more Quobyte faces.
Thank you so much for taking the time today, Joe, Bjorn, and Felix. I'd also like to say thank you. We would also like to say thank you to everyone who joined us today. The recording will be circulated in an email shortly, and have a great rest of your day.